Now we'll see overflow condition in 2's complement addition. Example, let's say you are adding 4-bit numbers. When you are adding 4-bit numbers, why overflow comes? When the number, the sum is not representable with 4 bits, then you get overflow. That is a simple idea. Example, you see, these two are the two positive numbers. Their sum is 7 plus 5, 12. This is 7, this is 5, right? 12 cannot be representable with 4 bits. Sir, we can represent, of course, but we are studying 2's complement representation, right? In that we have only these 3 bits to represent the value, correct? So maximum number is 7, not 15. So that's why 12 cannot be representable. Remember it. Take this case. Here these two are the negative numbers, and we know that maximum number we can represent in the negatives. Sorry, not maximum, minimum number. Minimum number we can represent in negatives is minus 8 with 4 bits. But now if you add minus 6 plus minus 7, you are getting minus 13. That cannot be representable. Here definitely you get overflow. Next, here you see one positive, one negative, then you never get overflow. Already I told you, because the number definitely will be in the in between this plus 7 and minus 1, hence it is representable. If you can represent 7 and minus 1, the number between 7 and minus 1 also can be representable. There is no overflow here. Now here, though these two are negative numbers, it is not compulsory that we get overflow, right? Yes, similarly, if there are two positive numbers, sometimes if the sum is less than, otherwise the sum can be representable, there will not be any problem, right? That is not overflow. Similarly, here it is not a overflow. Why there is no overflow, we'll see. So here, this is minus 8 plus 6 minus 2, right? The value of this one is minus 8 plus, this is 5 minus 3. Minus 2 plus minus 3 is minus 5, hence it can be representable. Up to minus 8 we can represent. So there will not be any problem. Now we have to find out easy circuit for this one. Let's do that. For that we are going to use carries. Okay. So let me show all the carries. So when you do addition, so let's recall 0, example, let's say 0, 1, 1, 1, 0, 1, 0, 1. Right. So here we are going to use full adder. Of course it is not required, half adder sufficient, but we are using full adder. Then for that we give carry here, that is C0 carry. So this C0 1, 1 we are adding, initially C0 will be 0, right? So then this is one full adder 1. So you get some, so this is C0, second full adder, this is full adder. So some carry comes from here, right? So that is C1. That and these two we add and you get carry, that is C2. So C2 and these two bits will be added, then you get C3. Then if you add these three, you get another carry, that is C4. That is a terminology. C4 means carry coming from the last 2 bits, right? Last 3 bits, and C3 is nothing but carry coming from these bits, these two last but 1 bits. Remember it. Okay. Now, so what I want to tell you is, so we can realize a circuit with C4 and C3. Okay. So C4 and C3 are going to decide the overflow. We will see that. For that I am going to develop a small theory. So first of all, one thing, when these two bits are zeros, okay, then still carry comes. No, you never get carry, correct? So remember one thing, when these two bits are zeros, what is going to happen? You see, assume that let's say C3 is 1. So C3 1 means what? This, from this section carry is coming. We know what is C3, already I told you, right? So carry from this section. If carry from this section, especially here in this problem, carry from this section is 1, correct? Yes. So that 1 comes here, then you are adding them. But still if there is no carry from this out, that means from this section. What is the reason? Just that is the case number 1. So what I am saying is, when C3 equal to 1, C4 is 0, then definitely that means what? So here these two bits are zeros. There is no other option. Recall. Sir, what? One of them is 1. If one of them is 1, if carry comes from this section, then that 1 plus this 1 will generate a new carry. So C4 will become 1, right? So if C4 is 0 means definitely the only case is when C3 1 I am talking about. When C3 1, C4 0, the case definitely that X3 equal to Y3 equal to 0. Remember it. Okay. Now in this case, observe. So these two are zeros. Now carry coming from here, which is C3, correct? Okay, I'm writing here. So 1 plus 0 plus 0, 1. So here you get negative number. Summation of two numbers, two positive numbers is giving negative numbers means what? Definitely there is a overflow, correct? So that means there is a wrong answer. When there is a wrong answer, the only reason is overflow. That's why. Remember the case is C3 1, C4 0. Now we'll observe other cases. That other cases, if you see, let's say carry is coming, C3 is again 1, but C4 is also 1. Just recall. When this will happen? When C3 1, C4 1, that means carry is coming from here, right? From here. Example here. So 1 plus 1, 0, 1 here, 1 plus 1 plus 1, 1 here, then 1. See, 1 plus 1 plus 1, 1 here and here 1, right? See, this is C3. So carry coming from this section. Then at that time, if these two bits are ones, or one of them is 1, what is going to happen? C4 is also 1. So there is no problem. Why there is no problem? So let me take the numbers here. 1 1 1 1 0 triple 1. We are considering the case where we are getting the carry here and we are also getting carry here. Okay. So for that, at least one of them should be 1. Then only it happens. If these two bits are zeros, then you don't get C4 carry, correct? So in that case, if you see 1 plus 1 0, 1 plus 1 plus 1 1, and here 1 and here 1, 1 plus 1 is what? 0, right? And carry 1. So did you remember? So see the values. It would be minus 1, it would be plus 7, right? 7 minus 1, 6, right? This is 6. But we have to discard this carry. If you can discard this carry, then it would be the right answer. That means what? Whenever there is now see again observation is when C31, C41, that is what the case here. So there is no problem here. Remember it. Okay. So no problem. That means it is not overflow. So finally, up to now, what is overflow condition? When C31, C40, there is a overflow, right? This case. Carry 3 1, but carry 4 is not 1, right? Now second case you see where you get, and one more thing here also you see. Here again C3 is 1, isn't it? So C4 carry is coming from here. So let me do calculation and tell me. 0 plus 1 1, 1 plus 0 1, 1 plus 1 0, right? Then carry is coming here. This is C3. So 1 plus 1 plus 1 is sum is 1, carry 1. At that time still there is no problem because of the sign extension. What happens is 11011 is equivalent to 1011 first of all. 11011 equivalent to 1011. So 1011 is a number, value is minus 8 plus 3, which is minus 5, is representable. So there will not be any problem. So finally then what is the other case where you get problem is this one. See 1 1 0. So here 1 plus 1 0. That means the sign bit is modified. So when sign bit will get modified? When these two are 0 if carry comes. Otherwise these two bits are 1. But carry doesn't come. In these two cases only there will be overflow. So finally this is all about observations. What you do is you take this kind of numbers and observe, then what you realize finally is C4 bit, C3 bit, their XR is 1. Then you are going to get the carry. Okay, sorry, overflow. Example, in this case C4 bit is what? 0, correct? Carry out is 0. Carry in into most significant bits or most significant digits is what? 1, right? Here especially at that time 1 XR 0 1, that's why there is a overflow. Second case, this one here, the reason for overflow is not having carry from this section, that means C3. So if C3 is 0 here and but C4 is that carry is 1 plus 1 0, then carry is 1. Here carry coming out. In that case also you are getting overflow because this bit becomes 0, but actually when you add two negative numbers, the answer supposed to be what? Positive. For positive, how can you have here 0? So that's why finally blindly remember C3 XR C4 is going to always detect the overflow. Let's generalize it. Okay. If you have n bits, okay, xn minus 1, xn minus 2, so on, x naught, and you have y naught, y1, so on, yn minus 1. When you are adding this n bits, then the overflow condition is, we know what is Cn, what is Cn minus 1 here, right? So Cn is nothing but a carry which is coming out from this most significant digits. Cn minus 1 is the carry carry going inside of these most significant digits. So their XR, Cn XR Cn minus 1 is 1, then there is a overflow. That's why this is the circuit, very simple circuit to detect 2's complement overflow. Remember it, 2's complement overflow. One more thing, in the exam they might give questions related to overflow. If they give different circuits, sometimes there is one more way of telling the same thing. We can detect overflow by this way also. What is that? I will tell you. These two bits, xn minus 1, that means this bit, yn minus 1, xn minus 1 0, that means xn minus 1 bar is 1, yn minus 1 bar is 1, that means xn minus 1 equal to 0. Try to understand. Xn minus 1 0, yn minus 1 0, and at what, whenever these last two digits are zeros, at what time you got the overflow? At that time your sum. So I will explain you, don't worry. So xn minus 1 bar, yn minus 1 bar, and sn minus 1 plus xn minus 1 into yn minus 1 Sn minus 1 bar. So this is also going to be overflow condition. Let us check. Example, what I want to tell you is, example, you have 0 0 1 1 and you have something 0. Let's take 0 1 1 1. So what is going to happen is 1 plus 1 0, 1, 1 plus 1 1 here, 1 plus 1 0 here, carry 1, right? So see here, when xn minus 1 is 0, yn minus 1 is 0, 0 bar will become 1, this 0 bar will become 1. At that time this sum is important. The sum 1 means what? Definitely when these two bits are 0, sum 1 means what? Definitely you are getting negative number when you add positive numbers. That's why, so this equation will detect this equation, this component. Now second case, when you have two negative numbers, 1 1 0 0, 1 0 1 1. Now you see, so there is no carry. That's why what is going to happen, you see, 1 here, 1 here, 1 here, 1 plus 1 0, and carry goes out. So this is again a problem. Why? Overflow. So two negative numbers are becoming positive number, their sum. That is impossible. For that, this case can be detected by this equation. Xn minus 1 is 1 and yn minus 1 is 1. At that time sum is 0, then definitely there is a problem. So this condition also we can use for overflow. Remember it. Okay. In GATE exam, if they give any equation, the best thing I will tell you, take the cases. Example, take this kind of cases. There is where there is an overflow. Simply substitute these values into equation. Okay. I will tell you with one example. Don't worry. But at this moment, remember these two equations. But in the GATE exam, if they give a new condition, because like these two, there might be another equation which which can be used as overflow condition. Then, sir, how to? Because we don't know that, right? So then, how to say that that is actually representing overflow condition? For that, the simple thing is, overflow logic, right? When overflow comes, right? Then in the options A, B, C, D. So there will be only one correct answer. Example, when let's say there is Cn XR Cn minus 1, but you don't remember. Now some other options are given, like Cn Xn something, some equations they have given. Really it is a overflow condition, otherwise overflow equation. Then that overflow equation should become 1 whenever there is a overflow. By substituting these random examples, like take some 4-bit numbers and substitute what is Cn, what is Cn minus 1 in all the options, and other variable values also. So whichever gives you 1, that is the overflow condition. Don't worry, I will explain with one example. So here what is the driving point or catching point is, for 2's complement addition, case number 1, that means one equation is Cn XR Cn minus 1. Okay, that is one overflow condition. Second overflow condition is xn minus 1 bar, yn minus 1 bar, sn minus 1 plus xn minus 1, yn minus 1, sn minus 1 bar. You know what is sn minus 1, right? Sn minus 1 is nothing but sum of these two positions, sn minus 1. Okay, so this is about overflow condition. See this question which is asked in GATE 2006 paper. They have given two n-bit numbers, b0 to bn minus 1, a0 to an minus 1. But don't get confused. c0, c1, so on, cn minus 1 are sum bits, not carry bits. Okay, but generally in our discussion we use these variables for carry bits. So you should be able to differentiate these two. So sum bits are this, and one more thing is given, carry out. What is carry out? which comes from the, the carry which comes out from the, most significant digits, C out, that is given. So that means when you add these two bits and the carry in, then you get carry out, that is given. So given only these parameters, we have to find out the overflow condition. That is a problem. So they have given options like this: C out dot an minus 1 xr bn minus 1 whole bar, an minus 1 bn minus 1 cn minus 1 bar plus an minus 1 bar bn minus 1 bar cn minus 1. So actually this is some bit. It is like Sn minus 1 in our discussion. Okay. Now this one, C out xr cn minus 1. Don't get confused. So when you are in hurry, you simply say that sir C is correct, because already you taught us that C out xr cn minus 1 is the overflow condition. But be careful, understand the concept clearly. Cn minus 1 in the question is not really our Cn minus 1. This Cn minus 1 is representing different thing here. That's why, so this option may not be the correct one. I'm not saying that it is wrong, but definitely we should see once, correct or not, because this Cn minus 1 is actually Sn minus 1 in our discussion, right? Now, sir, how to answer it? Don't worry. So, if you don't have option, actually option B is correct, because Cn minus 1 is what? Sn minus 1 in our discussion. Already I told you one more overflow condition, right? While discussing the concept, what was that? Cn minus 1 is Sn minus 1. Actually one more condition is An minus 1 Bn minus 1 Sn minus 1 bar plus An minus 1 bar Bn minus 1 bar Sn minus 1 is also overflow condition. Okay, of course. But sir, we don't know that, we don't remember it. Then what to do? Simple. Without knowing anything, by only knowing overflow condition, we can answer it. Take one example. Okay. So really one is the correct answer, all are wrong. Then definitely by elimination we can answer it. Take one example and substitute the values. Then really it is a overflow condition, that should become 1. Otherwise, really when there is a overflow, if that any equation is not 1, that is definitely not a overflow condition. Try to understand. Because to detect the overflow, the equation should become 1 whenever there is a overflow. Remember it. Now, when there is no overflow, this equation should not be 1. Correct? So, in that way also we can eliminate. Now, we will see with example directly. 0 plus all ones means minus 1. 0 plus minus 1 is minus 1. There is no overflow, right? Correct? So, it's a right answer. Now, overflow equation should become 0. Let's try. Directly let me substitute in option A. In option A, what is C out? Let me identify what is C out. In this calculation, C out is carry which is coming out from this last section. So, which is nothing but 0, right here. 0 plus 1, 1, 0 plus 1, 1, 0 plus 1, 1, 0 plus 1, 1. Here carry is actually C out is 0. Okay. For this example, we will try this. C out 0. 0 into anything is 0, then it is detecting. So, that means, so here there is no overflow. This option A is also saying that it is satisfying the condition. That's why I put a question mark. I don't know anything. Now option B. In option B, An minus 1, 0. This one Bn minus 1, 1. 0 into 1, 0. 0 into anything is 0. This component is 0. Now this one. An minus 1 bar, 0 bar, 1. Right? I am writing here. So here An minus 1 bar, 0 bar, 1 dot. Bn minus 1, 1, 1 bar, 0, 1 dot 0, 0, 0 plus anything, 0. There is no overflow. Here also there is, this equation is satisfying because it gives you 0. Now we'll go to option C. In option C, C out xr Cn minus 1. What is C out? 0, xr. What is Cn minus 1? Cn minus 1 is this bit, right? 1. 0 xr 1, 1. This is detecting the overflow when there is no overflow. That means absolutely option C is wrong, right? Now we'll take this option D. So with first example. So here An minus 1, what is that? 0. XR Bn minus 1, 1. XR Cn minus 1, some bit, 1. So 0 XR 1, 1. 1 XR 1, 0. So overflow supposed to be 0 and this is also now at this moment 0. So it is satisfying currently. So I can't say anything, that's why question mark, right? Now we will see second one. So one more pattern. Here also there is no overflow, right? 1 plus 1, 0, 1, so 1 comes here, I'm sorry. So it is not all zeros. 1 plus 1, 0, you get 1 plus 1 plus 1, 1. Then here you get 1, 1 plus 1 plus 1 is 1. So here you get 1, 1 plus 1 plus 1, 1. Carry out is 1, right? So now important things are C out 1 and An minus 1, 1, Bn minus 1, 1, Cn minus 1, 1. Let's apply. C out is 1. So now don't try option C. Option C already gone, right? Now we have 3 options. C out is 1, 1 into, so an minus 1 XR bn minus 1, 1 XR 1, 0, 0 bar 1. So this entire thing will become 1. So 1 dot 1, 1. So it is detecting the overflow, but there is no overflow because minus 1 plus minus 1 is minus 2. So this is minus 2, correct? So minus 8 plus 4 plus 2. 4 plus 2, 6, minus 8 plus 6 minus 2. There is no overflow. Sir, but we got carry out. Did you remember? Already I told you in 2's complement arithmetic, when you add two things, the last end around carry should be discarded. Okay. So we discard it. So see, this one is the result, right? 1110, it's correct one. So there is no problem. So there is no overflow, but C out is detecting the overflow when there is no overflow. Option A is detecting the overflow when there was no overflow. That's why eliminate it. Now go to other options. Now B and D. Since we know that B is the correct answer, we try with D. Okay, sir, but how do you know that B is correct answer? Already we have seen that this is representing, overflow equation in our discussion. If you have still doubt, just substitute now. An minus 1, 1, Bn minus 1, 1, 1 into Cn minus 1 bar. Cn minus 1 is 1 here, right? So bar 0. 1 into 0, 0 plus. So here an minus 1 bar, 1 dot 1 bar, 0. 0 into anything is 0. So 0 this component. 0 plus 0, 0. Finally you get 0 here. So there is no overflow. That means this at that time the correct equation should give 0. It is giving 0, but still I am putting question mark because only one overflow condition if something detects, we can't say that it detects all overflow conditions. That's why still open question. Now come here. So now again what is an minus 1? 1 XR Bn minus 1, 1 XR Cn minus 1. What is Cn minus 1? Here 1, right? Yes, we have seen. 1 XR 1 XR 1. 1 XR 1 0, 0 XR 1 1. So it is detecting the overflow when there is no overflow. So this is also wrong option. So finally we eliminated some 3 options. Then this will be the correct answer. Okay. So in that way I can say that this is representing overflow condition.